So in D178B, if you look at tool qualification, again this is a repeat from what I said in earlier slides, the qualification of a tool is needed when processes of D178B are eliminated, reduced, or automated by the use of the software tool without its output being verified. So a much simpler way of looking at this definition is try to answer two questions for your development or verification tool. So remember, for each tool you have, either it being a development tool or a verification tool, you have to answer two questions. A, is the output of the tool used to support compliance for all of part of a required objective? In other words, you're going to check out all your objectives that you have in D178B. You're going to check out, is this tool used to support compliance? In other words, is it eliminating, reducing, or automating one of these objectives? And then the second question that you need to answer is the output of the tool verified as correct by some other process? If the answer is yes to the first and no to the second question, then the tool must be qualified. You know, if you have a tool that eliminates, or like this, you have one objective in D178B, you're going to use a tool to implement that objective to, be compliant with that objective. If you not verify the output, you need to qualify it. If you independently, or if you verify the output, you don't have to do so. Okay, so if another way to look at this is actually given in one of the FA notices, 811091, and there it actually says, okay, it formulates three questions, and it says, okay, a tool should be qualified if the answer is yes to all three of the following questions. Can a tool insert an error in the airborne software or fail to detect it? So this really means, is it a development tool or is it a verification tool? And then, will the tool's output not be verified? In other words, are you not going to look at the tool's output and make sure it's fine? And are processes eliminated, reduced, or automated? So if the question is yes to all three of these questions, then the tool should be qualified. So it is kind of a different way of looking at it than these two questions. So for example, let's look at using a difference tool, like in Linux that would be diff. This tool takes really two input files and produces the difference between them. Now you could use, you could be using this, for example, to demonstrate that all changes to the software component, requirements, code, have been verified by identifying all changed sections and then manually looking for tests that have evaluated the changed part. Yeah. So this is an example. Huh? I take the diff tool and now I'm using it to demonstrate that all the changes that I made to my software component, both requirements, for example, requirements of the code, have been verified by identifying all the changed sections and then manually looking if all the tests have been evaluated for just these changed portions. Now the question is, okay, what kind of tool is it? Now, does it introduce, does it change the code? No, it doesn't. It's a verification tool. So do we need qualification? Now, if the tool is used to support, for example, the software configuration management objective for change review, yes, you must qualify it, because now what you're doing is you're actually using the tool to implement or find compliance with one of these objectives. So unless you're independently going to verify, it, the output, by yourself in an other way than just using the tool, you need to qualify it. On the other side, if you have a tool that's used to double check a manual change review, here the keyword is double check. The tool is not the only thing doing the check or like doing the change review. You double check it. So you have maybe some people doing the change review and then use the tool to double check it. So in this case, it doesn't have to be qualified, because in that second case, the answer to this question 2 would be no, and the answer to this question B would be yes. So now, what's very important, and I've said this before a couple slides ago, that a verification tool is not necessarily a tool that replaces verification tests. So for example, if you have a tool that instruments the code for testing and then afterwards removes the instrumentation code. So in this case, this is a verification process that this tool is helping you with a verification process. You instrument a code so you can use it to test that particular piece of code. It's a verification process. However, the tool actually changes the source code. So if there's a mistake in that tool, it could introduce errors in your final product, your executable code, or even the source code here. So that makes it a development tool. Yeah? And of course, realize what I mean by instruments, that we add additional code solely for test purposes. That means you have to really get rid of it. If you forget something, you may change that source code while you use this tool. So this is really kind of confusing in a sense. So what you see is in ee6083C, if you look at tool qualification, the terms development and verifications tools are really no longer used. So instead they came up with this thing called tool qualification levels, and on the next couple slides I'll talk about it. Now, in addition to ee6083C, they came up with a supplement on tools, and in that supplement now they're going to have tool-specific objectives. And this tool-specific objectives document, let me go check out where it is. Oops, DO330. In DO330, kind of follows the same layout for the for objectives and the document exactly as DO178C, but it focuses on tool qualification. Okay, so let's check it out. So in this particular table, on the left side, it talks about the DO178B tool terms, development tools, verification tools. On the right, indeed, it gives you what the nomenclature we use in DO178C. In DO178C, we define 3 criteria. Criteria 1 is a tool whose output is part of the resulting software and thus could insert an error. In other words, that's exactly what we had in DO178B, which is called a development tool. Criteria 2 is a tool that automates verification processes and thus could fail to detect an error and whose output is used to justify the elimination or reduction of A. verification processes, other than that automated by the tool, or development processes. Then criteria 3 is a tool that within the scope of its intended use could fail to detect an error. Yeah? So basically we took these 2 different tools, we broke them down into 3 different criteria. Now, so your question is going to be, when do we do tool qualification? So you kind of have to follow this particular flow chart for that. So first of all, you're going to check out, okay, this tool that I have, where am I going to use this in my software lifecycle? And then the next question is, does this tool eliminate, automate, or reduce any processes in DO178C? In other words, am I going to have one objective and we're going to use this tool to either reduce or automate it or eliminate it even? Yeah. If it does, if it doesn't, there's no qualification needed. If it does, then you have to ask yourself the question, is the output of the tool verified? If it is verified, again, you don't need qualification. Because what you do is you kind of double check, you cross check the output of that tool. If it's not the case, then you need to check out which one of these 3 criteria applies. And you need to identify what qualification level you need. Okay? And then what happens in DO330, there's objectives associated with these tool qualification levels. So for example, if you have a proof tool, it's used for source code verification, and also, in other words, this is a criterion 3 item. It could actually fail to detect an error. Reduce robustness testing is a criterion 2 item. Okay? So in 2 is kind of in criterion 2, you really gonna again, it's a tool that automates a verification process and could fail to detect an error, and, very important, whose output is used to justify the elimination or reduction of certain process, either verification or development. So in these particular cases, reduced robustness testing, you try to reduce the amount of robustness tests you need to perform, hence criterion 2. Here you actually remove defensive code, which is development, so you actually reduce a particular development process, so it's criterion 2. Okay, so if you look at, what you're going to say is, okay, so for each tool you can say, if you make it to this point, okay, what criteria applies? And depending on what assurance level you want to guarantee and what criteria apply, you come up with a particular tool qualification levels following this table. So if you have a DO178, if you need to get approval for this software product to the assurance level A, and you find out this the tool actually criterion 1 applies, then the tool qualification level is 1, which is the most stringent one. Whereas if it's a level D piece of code and it's criterion 2, it is the most stringent tool qualification level. Yeah? So in this case, you make sure that you take your assurance level, you check out what criteria applies, and then you find your tool qualification level where 1 is the most stringent, 5 is the least stringent. So then what you need to do, based on that tool qualification level that you have determined, you're going to go and look in the objectives tables of DO330. So this is DO330 to find out, okay, what things do I need to do? What objectives do I need to meet? And for example, and I think I have an example on there on a later slide. So key things in DO178C, rather than 2 different tools, now we are going to have 3 criteria. You're still going to have to ask yourself if you eliminated, automated, or reduced a particular DO178C process. If the answer is yes, you need to make sure you're still going to check out if the output of the tool is verified. And if not, you need to determine your tool qualification level and find out what objectives that you're going to need to meet for this tool.